Hello viewers, a very warm welcome to all the viewers of this channel Wisdom Jobs. In this video, I am going to explain you some basics about the concepts of unit vector and position vector, which are very useful in the problems based on Coulomb's law, etc. etc. Okay, so this concept is very important because this forms the basis for many important problems in the forthcoming classes in EMTL, in GATE or any other examination, competitive examination. Okay, so with this note, I am going to start the class on position vector and unit vector. So before going to the concept of position vector and unit vector, I am going to request you all to please do subscribe to our channel wisdomjobs.com, because we are going to upload many useful videos for you, and these videos are very useful for you and your friends also, and so I am requesting you all to share these videos to your friends. So with this note, let us start the topic. Now, as I told you in the last video, we have got three coordinate systems of expressing a point in three-dimensional geometry. What are they? They are basically the Cartesian coordinate system, in which any point is represented as P of x, y, z, and all these three coordinates x and y and z are distances. Next, coming to the second coordinate system, it is cylindrical coordinate system, and it is expressed as P of phi and z. Similarly, if you take the third coordinate system, it is spherical coordinate system. Okay, and in this a point is expressed as r, theta and phi. So what are the unit vectors in the three coordinate systems? If you observe, is in Cartesian we express the unit vectors as ax cap, ay cap, or and az cap. And in some textbooks, the same notation changes to I bar, j bar and k bar. So I bar is similar to ax cap, j bar is similar to ay cap, and k bar is similar to az cap. Similarly, for the second coordinate system, the unit vectors are a rho cap, a phi cap and az cap. Okay. Next, in the third coordinate system, the unit vectors are ar cap, a theta cap and a phi cap. Okay, so these are the unit vectors in the three coordinate systems of the point representation. Okay, now if I go for the concept of position vector, okay, so if I go for the concept of position vector, any point has got a position vector. Okay, any point has got a position vector. Now if I wanted to represent the position vector of any point in Cartesian coordinate system, let me say, okay, so the Cartesian coordinate system has got unit vectors ax, ay and az. Na? So if I am let me take a point a, b, c. What is a, b, c? A is the x coordinate of the point, b is the y coordinate of the point, and c is the z coordinate of the point. Right? So for this point, a into ax cap plus b into ay cap plus c into az cap. Okay. So these are this is the position vector of the point A, B, C. Now if I take one numerical example, let me say a numerical example is P 2, 3, 4. Right? For this point, what would be the position vector? It is simply multiply the x coordinate with its respective unit vector, that is ax cap. So 2 into ax cap. Next, you have got multiply the y coordinate with respective unit vector along y direction, that is ay cap. So plus 3 ay cap. Okay, and lastly 4 az cap. This is one way of representing the position vector. Another notation also is there, as I told you. I bar, j bar and k bar, if they are the unit vectors, the same position vector I can write it as 2. So I bar plus 3 j bar plus 4 k bar. So in these two notations, anyone is correct. So some textbooks follow the first notation and some textbooks follow the second notation. Next, if I take one more example in cylindrical coordinate system. So in cylindrical coordinate system, let me say a point P is written as let me say 5, 36.86 degrees and let me say minus 2. So this I can write it as 5 into a rho cap. Next, plus Now 36.86, better you convert it into radians. Okay, so if I convert that into radians, I am going to get it as something like pi by 5 and pi by 4. So 36.86 roughly it is almost pi by 5. So I can take it as 0.2 pi I bar. I mean a what is the unit vector for the angle a phi cap. Okay, next lastly minus 2 az cap. So this is the exact point representation, I mean the position vector representation of the given point in cylindrical coordinate system. Okay, next if I take the circular or spherical coordinate system, let me say 5 comma minus pi comma plus pi. Okay, so plus pi. So if I take this point, okay, so of course these two are in radians, right? So the point representation, the position vector representation for this point would be what? It would be 5. What are the unit vectors in spherical coordinate system? A r cap, next minus pi a theta cap plus pi a phi cap, right? So in this way I can write the position vector of a given point in any given coordinate system. Okay, now let us move to the next concept, which is unit vector. Now if I take the unit vector concept, let me go for unit vector. So if I go for unit vector, just let me say for unit vector we need to have 2 points. So let me say P1 is some x1 comma y1 comma z1, okay, and P2 would be x2 comma y2 comma z2, right? So for this the position vector is what? It is it is x into ax cap plus y into ay cap plus z into az cap, right? Now for the second point, what is the position vector? It is actually it is x1, y1 and z1, and here it is x2 into x cap plus y2 into ay cap plus z2 into az cap. Okay, so these are the position vectors of the given 2 points. Now if I wanted to determine the unit vector along the line joining these 2 points P1 and P2, then how to determine the unit vector? So we represent it as P1 P2 cap. Okay, so that is just subtract the x coordinates and multiply with the respective unit vector, that is I bar or x cap. So it is x2 minus x1 into a x cap, next plus y2 minus y1 into a y cap plus z2 minus z1 into az cap, this divided by the magnitude of this vector. So what would be the magnitude of this vector? Simply under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, so this is the unit vector along the points joining P1 and P2. Understand? So of course if you wanted to determine the unit vectors for cylindrical and spherical, in the same way just subtract the second point, subtract the first point coordinates from the second point coordinates respectively with respect to all the 3 directions, and multiply the respective coordinates with difference coordinates with the respective unit vectors. Then you are going to get the position vector of a line. That position vector of that line you just divide it with the magnitude, then you are going to get the unit vector. Understand? So if I do one problem, so you can easily understand this concept. So let me take the points P 2, 3, 4 and Q. Let me take it as 3, 5, 6. Okay, 2, 3, 4 and 3, 5, 6. So for this 2 points, let me determine the unit vector. So always I told you the second point minus first point. So which is the direction of the point here? The line is joining P to Q. So since it is 2Q, Q is the second point. So PQ is equals to just I write like this: Q bar minus P bar. What does it imply? The position vector of the Q point minus position vector of P point. So it is simply, what is it? It is 3 minus 2. I'll write it first step so that you will be not confused. So 3 minus 2 into I bar plus 5 minus 3 into J bar plus 6 minus 4 into K bar. Okay. Now this is a position vector. See, if you observe, I am not putting any cap here. So if cap is there, it indicates that it's the unit vector. Since cap is not there, it is simply the position vector of the line. So what would be the unit vector now? Simply it is cap. So PQ cap would be PQ upon mod PQ. Mod PQ. Okay, so that is what is modulus of this now? It is simply if you observe, this would be how much? 3 minus 2 is 1. 1 into I bar is I bar plus 2 j bar plus 2 k bar. So what is the magnitude of this vector or modulus of this vector? It is under root of 1 square plus 2 square plus 2 square, which gives you under root of 9, which gives you 3. So the modulus of this is 3. So just I bar plus 2j bar plus 2k bar whole divided by 3. This would be the unit vector PQ. I mean along PQ. Okay, so if I further simplify this, what do I get? The further simplification gives you, therefore PQ cap would give you 1 by 3 into I bar plus 2 by 3 into j bar plus 2 by 3 into k bar. So this is how you are going to determine the unit vector of a given 2 points, between 2 given points. Okay, so with this I am going to stop this lecture. So in the next class, in the next video, we are going to discuss about the concept of Coulomb's law, and if time permits, we will go for electric field intensity. Okay, so if you have got any queries in this topic, please do subscribe. Please do express your doubts or queries in the comment box, and as and when we find time for you, we are going to revert back to you and give the answer for your doubts. Okay, thank you. Have a nice time.